Okay, hello, good morning, and good afternoon, and good evening, everyone. First of all, I would like to say thank you for joining our poster presentations entitled Novel Approach on Biomarker Analysis on Oil-Based Mud Contaminated Samples, a case study from Well Alpha in onshore Northeast Java Basins. Before I begin my presentations, I would like to acknowledge our first author, Mr. Andi Mardianza, Mr. Dwi Meidian Sulistyo, and Mr. Muhammad Fajar from PT Pertamina EP that without them, the paper here cannot be presented in PIT-IAGI 2020. Last but not least, I also want to acknowledge Mr. Eddy Ariyono Subroto, our advisors that have give us some advice and guidance through this paper. First, I will begin my presentations with the introductions. Then I will start with the petroleum geochemistry study is very important for the beginning of hydrocarbon explorations, since it can enhance the success rate of exploration until 64% according to Webels 1985. Petroleum geochemistry also could provide informations on the occurrence of source rock, the very important element in the petroleum system that are very helpful to understand the petroleum system within the basins. One of the problems that are crucial for geochemists is contaminated samples, since the contamination could come from oil-based mud, and when the OBM is applied, the cutting samples will be contaminated. This is the consequence of the appraisals well that are drilled to improve the understanding of petroleum system in the basin deep. Therefore, the drilling well will encounter high pressure and high temperature conditions. So the use of OBM is not inevitable. Reactive shales also compels the drilling process using OBM instead of WBM. The reason is that the WBM contact with the reactive shales can make the shale swell, so there will be a stuck pipe. So in this figure, the contaminated source rock must to be assessed first because it could lead to erroneous interpretations. The OBM, however, could be tackled with several methods. There are a lot of research before this that have proposed several methods to tackle OBM contaminations, such as changing the solvent for OBM treatment, according to Niranjan et al. 2013, and numerical methods to correct the contaminated samples, according to Wenger et al. 2004. Our study also compare and propose the biomarker interpretation with all available methods and also propose a novel method for treating the OBM contaminated sample. The data we use here is 11 OBM treated cutting samples retrieved from Well Alpha in the Northeast Java Basin onshore that are analyzed using GC and GCMS. The contaminated samples also analyzed using GC and GCMS together with the pure OBM samples. The GC and GCMS analysis also results on the normalized alkane fractions that will be used for further mathematical correction proposed by Wenger et al. 2004 methods. We focus also on characterizing the GC results from the OBM used on the drilling process of the Well Alpha. The chromatogram from pure OBM samples compared to other well-known OBM references. Finally, the biomarker interpretations from the method we propose, Wenger et al. Methods, the numerical methods, and Niranjan et al. Methods, changing the solvent, organic solvents, will be compared. Here is the detailed workflow for contamination assessment that we propose. First, the contamination assessment, we use two data, contaminated samples and pure OBM samples. The contaminated samples then are treated using OBM. There are two choices, two options, which are DCM treatment and the toluene treated samples. Then the DCM treated samples together with the contaminated samples and the pure OBM samples are analyzed using gas chromatography and gas chromatography mass spectrometry. Then the chromatogram obtained from the gas chromatography are interpreted from the DCM treated chromatogram, OBM plus bitumen chromatogram, this is the contaminated samples, OBM chromatograms. Then we also use Wenger et al. Method, the numerical methods, so we obtain the corrected chromatogram. All of the analysis will be interpretations, and the interpretations obtained from the three data will be compared to test its effectiveness. First, we will go to the first method that are proposed by Niranjan et al. 2013. After consecutive hours of treatment, 120 hours for toluene extraction and 53 hours for DCM extraction, we can see here in the figure 3, the samples are being analyzed for its basic geochemical parameters, such as TOC, S1 values, and S2 values. Both treatments are clearly successfully remove the OBM. However, the OBM treatment using dichloromethanes and with additions methanols have high significance on S1 composition compared to the toluene treated samples. This suggests that the DCM treatment is more powerful and must to be put in high cautions. Why? Because DCM not only successfully remove the OBM, but also remove the original organic matters. So it could also lead to erroneous interpretations. Now I want to give you the examples of the contaminated OBM. Here is the chromatogram obtained from the contaminated OBM samples. This is the pure OBM chromatograms, and this is the treated OBM chromatograms. As you can see here, the pure OBM contaminated shows a strange patterns with the occurrence of the alkene peak. It is strange to find the alkene peaks since it should be not occurred in source rock samples an alkene peak. Therefore, the GC results from the treated OBM also produce ambiguous peak. Biomarker interpretation from the OBM treated samples could not be taken since the carbon fractions has been completely removed by the DCM treatment. But if we want to forceful to try hardly to interpret the biomarker, we only can conclude that the low Priston per Vitin ratio from ngimbang formation indicates that the ngimbang formation is deposited in the suboxic environment. Now we can see that the changing the organic solvent into another solvent is still same. It's not change the conditions for analyzing the contaminated samples. So we use another methods proposed by Wenger et al. 2004 with the numerical methods. The normalized alkane fractions obtained from GC are plotted into bar charts together with the corrected GC data. So this is the contaminated samples, the bitumen plus OBM, and this is the pure OBM samples. The degree of contaminations is derived from the corrected data divided by the contaminated data. How about correcting the OBM? The correction of OBM is just subtract the bitumen OBM minus with OBM. and we will get the corrected bitumen. The degree of OBM contamination samples, however, from the 11 samples that are analyzed range from 21% to 44%. Now, after the samples are corrected, the normalized alkene are corrected, the 11 samples, all of the 11 samples show a unimodal peak on C15 to C19 alkane. This indicates that the source of organic matter for nyimbang formation is algae or plankton. This method is more effective, simple, and easy compared to the first method, but validity should be considered since the assumption used by Wenger et al. Is 100% untrue. Validity should be considered since the OBM is not 100% soluble to the GC, so there could be a little error of the results. Therefore, we propose our methods. The basis is the first method that Niranjan proposed by changing the organic solvent for the OBM treatment are quite ineffective because the carbon fractions are completely removed by the treatment. Then the numerical method also still have weakness due to the assumption used by Wenger et al. That the OBM actually not 100% soluble. So we use and propose a novel approach that are focusing more on the pure OBM samples. So we just characterizing the OBM samples, the pure OBM, while the previous research more focused on numerical methods and changing the organic solvent. The OBM is characterized for its biomarker characteristic then compared to other OBM references. This is the OBM, other OBM references. We have Sarapar oil-based mat, Saraline oil-based mat, and then we have the high point oil-based mat. The pure OBM samples, here, you can see here, did not have pristane and phytane based on the characterizations. No pristane and phytane are observed. That is typical of synthetic oil-based mud. This is correspondent to the drilling report that the well alpha are drilled using the SOBM. Then our OBM chromatogram also has a quite similar pattern with the Saraline oil-based mud, but without the occurrence of pristane and phytane. Therefore, the pristane, the original pristane and phytane are not affected by the OBM. So the depositional environment still could be determined. So in our proposed method, it is important to observe the OBM chromatogram peak and compare it to the model proposed by Yang et al. 2009. The biomarkers that are very powerful for depositional interpretations, such as the tricyclic terpene and the styrene, are on the NC21 to NC29 alkane domain here. While the most powerful pentacyclic terpene that have a wide variety to interpretations is on the C27 to N32 alkane domain. The peak distribution of the OBM could affect each alkane domain so that some biomarker interpretation would be unreliable. Now, as we can see here, our OBM samples have a low fraction above NC22, suggesting that the OBM not affect the C21 to C29 alkane domain, so the tricyclic terpene and styrene biomarker are not affected by the OBM. Therefore, we still could maximize the interpretations whether the samples are contaminated by the OBM. So interpretation of our samples with our proposed methods are our OBM chromatogram show a low peak of carbon below NC22 alkanes compared to the peak above NC22 alkanes. This gives us insight that the GCMS still could be done on styrene and pentacyclic terpene because the styrene and pentacyclic terpene domains are undisturbed by the OBM. The interpretation could be still maximized even when the samples are contaminated samples. So we come to the conclusions here. Previous studies focus on changing the solvent, the first methods, and the numerical methods to correct the contaminated samples have been proposed by the previous researchers, and we have already demonstrated those methods. The first methods is quite ineffective. It's removing the all carbon fractions, so biomarker interpretation could not be taken. Then this is, however, it's good for the samples that have taken freshly from the subsurface. But most of the data in the oil company have been analyzed using GC and GCMS. So we must to maximize the contaminated samples. So we just discard the first method and we change to the second methods and our proposed methods. The numerical methods is quite effective, simple and easy, but it still have the weakness, the assumption not 100% OBM are soluble to the GC. So it also could give us error results. The proposed methods, our proposed methods could be very applicable for geochemical assessment on contaminated samples. We suggest that the interpretation from the available data still could be maximized even when the samples are contaminated samples. And last, the acknowledgements. The authors would like to acknowledge PT Pertamina EP that have provided and give us permission to use and present the data so that this paper could be published and present on PIT-IAGI 2020. And here is our references. That's all of our poster presentation. Thank you very much. Please feel free to give us some questions and have some discussions. Thank you.